Hello, everyone, and welcome to the webinar. This is Sydney speaking, and today's webinar will be actually talking about prismatic parts, actually iMachining 3D on prismatic parts. Now, just want to give everyone a little recap of what we had. The past couple of weeks, past 5 weeks in fact, we've had the webinars on the issue of automatic feature recognition and machining, AFRM. Those webinars included pocket recognition, chamfer recognition, drill recognition, all the automatic hole recognition and machining, as well as the hole wizard parameters using the SolidWorks hole wizard parameters plus the machining process. All this was done showing you all the power that we have in automatic feature recognition and machining. Now, however, there was one equation that was always missing. And that's what we're going to do now. We're going to be showing you actually iMachining 3D for prismatic parts. That, together with all of the other AFRM options, is actually one complete, it's actually the ultimate AFRM package, together with the iMachining 3D for prismatic parts. And we'll actually take a look in this webinar how we do this, how we can do this on all these different prismatic parts. We'll go into depth trying to explain the ins and outs inside the iMachining iMachining 3D for prismatic parts. So let's basically get started. Okay. Well, what exactly are we doing? Well, we'll start off by showing you the differences between iMachining 2D and iMachining 3D for prismatic parts. Now, when we're talking about prismatic parts, we're talking about parts such as we see on a screen now, regular electronic housings, for example, parts that we have really deep pockets. All of these are what we call prismatic parts. Okay? What I'm going to first do is actually show you a specific part, the way it was done in iMachining 2D, and then we'll show you what was done in the iMachining 3D. And then after that, we'll continue on with going deeper into iMachining 3D for prismatic parts. So let me switch over to my part itself. And I believe you should be seeing it now. If we start off with the part that we see on our screen, what you see is very simple. This is a pretty deep part. If I go from this upper level down to the very bottom over here, we're talking about 113 millimeters in depth. Okay? Now, this was done originally with iMachining 2D. It was done very well. However, when we did this in iMachining 2D, for every single step that we had to go down, you can take a look inside the part itself. We have a level that goes from here up until this level over here. Okay? From here to here is a total of 95 millimeters. We have another step that goes down to there. We have another step that goes down even further lower than that. We even have these two steps over here, which are not the same height as well. So in order for me to do iMachining 2D for all of this, I have to do several different roughing operations in order to get it working efficiently around those areas itself, to get to each depth individually. And for each area, I need a separate geometry. So let's actually go into some of the operations that I have over here, and we'll see exactly what this involves. If I were to take the first operation, you can see my geometry at this point is going around the part itself, just around the outside area over here, okay? And I'm not going to go obviously all the way down, because if I did that, then I would actually mill away those steps. I'm just going to go down to a specific step. Okay. Now, next I have my tool. in this particular case, I have a 20 millimeter end mill, which is actually a nice tool as far as the amount of material it can take off. It's a pretty massive tool for this kind of work, which is actually very good. But my limitations with this particular tool was that I can only be outside her holder no more than 90 millimeters. Okay? Now, if you remember correctly, I have from the top over here up until the bottom over there, I have a total of 95 millimeters. Okay. Now, so in this particular case, I have my upper level at 80, at 0, and I'm just going to a total depth of 80 millimeters. Okay. My technology wizard is taking it down in 3 steps. I'm not doing anything special over here. Let's see exactly what's going to happen over here. Now, we'll run a simulation. I'll do this using Solid Verify. And you'll see it's actually, let me slow it down a bit, going on each step. You can see it's doing the really efficient morph spiral cutting around the part. It's actually working very well. There's nothing wrong with this. Okay? Everything is working very well. Okay? Let's go further down. It does this to each level that it has to work on. But note, it only went down to this level here, to 80 millimeters. Okay? Now, in my next particular operation, I decided already to start off with my rest rough for that particular geometry, since I was already in that geometry. So I did a rest roughing operation just to finish out, rest material operation to finish out those corners. But then I wanted to go down to the actual step down over there. Now, I used the same geometry, but this time I had a smaller tool. But this tool actually was made specifically that I can go down deep. But I don't want to take heavy cuts with this because it is sticking out a large amount. So I took that really deep, heavy cut as much as I can up until that area up until 80 millimeters as much as I could. Now, the tool, it's the geometry, like I said, the exact same geometry I had before. The tool, in this particular case, is a 16 millimeter end mill, which is also still a pretty sturdy tool. But this one is outside the holder of 120 millimeters. So it can actually go down practically to the bottom of the part itself. Now, in this particular case, my upper level was minus 80. That's where I left off last time. And my pocket depth went a total of 15 millimeters down to this step over here, as you see, to minus 95. The other tool cannot go down here because it was sticking out of the part. It was sticking out of the holder. It only had up to 90 millimeters, so we couldn't do that. Okay. When I run my simulation on this, you'll see that now it's running up until that area, doing the morph spiral, but not going down up until the wall itself. Now, obviously, with the other tool, I couldn't go all the way down as well because then the holder would have also hit this. Okay, so I was able to use this tool for that. Now, for my next operation, I still have to go further down. So in my next operation, if I took my next geometry, you can see my next geometry was a little more involved. It went around these parts over here, and I was able to do actually a very good geometry around it, but doing something like that involves a lot of work, a lot of chain picking. It was a lot of work to do this. I did it. It was fine, no problem, but there's a lot of work involved. Okay? Again, in this particular case, my levels only went down a total of 4 millimeters. If I take a look at the simulation from this point on, you'll see that now it's working with that exact same tool on a different geometry, clearing out that area over there, and leaving over these steps over here up until where it had to go to. Okay? I still had to go further down, so my next operation, taking a look at this geometry, it included that same chain I had before, plus this one over here. I didn't include this one because I want to mill down now from this height over here up until this height. Okay? Again, you can see my levels, a total of 6 millimeters. Simulate. I'll run this pretty quickly now. And you can see now it's going down, milling around that step. And now I have to go down to the very bottom. So when I go down to the very bottom in the next operation, if I were to show you the geometry, this already included both of these. And now it's going to go down from this height over here up until the floor. Okay, the same tool, levels, a total of 8 millimeters, going down to the floor itself. Running my simulation. You can see now this one finishes off the floor. And you can see our two little studs at the very bottom over there. Okay, then we're just left with the rest roughing operation. And then again, that I also had to do individually for all of those over there as well. Let me actually run now just a simulation on all of these iMachining operations that I have over there. And I'll actually simulate them using the HostCAD. Now, I want you to pay attention to the amount of time this took. Okay? And we'll take a note. You see it's machining all of the edges. You can see it's going all the way down. And if we take a look at the time, jot this down for a moment, 45 minutes and 36 seconds. We'll talk about the time a little later on, but just remember this. Okay, now let's take a look at how this was done. Now, this is actually done pretty efficiently. It's done pretty well. But now let's take a look at how this is done using iMachining 3D. Okay, first of all, I have here a total of 3 iMachining operations. And this already includes the rest material for all of those corners. If I were to take a look at my first operation, you'll note the following. First of all, I have my geometry. My geometry is the entire target, so it knows everything that's there. It also knows, if I go into define, I'm not going to do anything, I just want to show you that it also knows to cut only where there is material left over. So if I go to show 3D, it's showing me what material has to be cut out. Okay. Now, I'm going to use the exact same tool that I did there in the beginning last time, that 20 millimeter end mill. That's outside of the holder, a total of 90 millimeters. Now we know with the holder, it can't go all the way down on the walls, but we have here an option which we don't have in iMachining 2D, something called holder collision. This checks the wall that makes sure that the holder does not clash into the wall itself, and it actually changes the tool path so that the tool can go as deep as it possibly can. You can see my levels are set all the way down to the bottom, okay? Straight to the bottom, that's where my levels are set. Let's take a look now at the simulation in this particular case. We'll use Solid Verify, and note the following. It starts off very similar to the way the other one started out, doing those exact same cuts, more spiral cuts. But now look what happens when it went further down and it got too close, it got to the area where it can't go any further in. It actually moved itself away, so this way it's clearing away all of this material with that larger end mill. Okay? Taking a look further down, okay, you can see how it's actually machining all of those areas itself. Okay? Very bottom over there as well. Now take a look at the side. You can see even that the holder is inside the part, but it's being protected so it doesn't go too far in. This is something you cannot do in iMachining 2D. If you did this in iMachining 2D, you would have to make a separate geometry, a separate operation just to do something like that. But note, this went all the way down, going as far as it possibly can, getting the most of the material that is left. So all that's left now for the next operations is just to work on these areas over here. So if I were to go into my next operation, you can see I'm using the exact same 16 millimeter end mill. Okay, and if I go back to my geometry and go to working area, what do we see over here? we see that it knows exactly what material is left over to machine. It shows it. You can't make any mistake about that. So it knows to work only in those areas. Okay? Like I said, we have our tool, 60 millimeter tool. Levels the exact same thing. Let's take a look now at our simulation. You see that tool now is just clearing out those corners that we did before, plus these areas as well, going all the way down as far as it can into the part itself, machining out everything that's there. And then the last operation is just doing the rest machining. Now let me just actually run now the simulation on these three parts and these three operations. Now you'll note total of 3 operations as opposed to what I had before of 11 different operations. And I did not have to pick a different Z level every single time. No chaining, nothing of that had to be done. Let me run now my simulation on this, and I'll start, and I'll actually do it again with HostCAD. And we'll run it down pretty quickly towards the end. You'll note, let's take a look at the time. The time in this particular case, remember now the first tool in this case was able to clear out a lot more material at the bottom. So there was a lot less that was left for the smaller end mill. Okay? This one took 29 minutes and 33 seconds as opposed to 45 minutes, 36 seconds. That's a difference of 16 minutes. Okay? Now, let me just show you a little chart that I have over here on this particular part. We're talking about this part over here where they had to do a batch of 140 parts. Now, when this was done originally, years ago with the standard 2.5D milling operations, this took over 2 hours, 2 hours and 16 minutes to do. Now, with the iMachining, when they moved over to the iMachining 2D, it took him 45 minutes. So that was 318 hours opposed to 106 hours. Okay? So in that particular case, with the iMachining 2D, they already saved a lot. 211 hours of saving time. In other words, 67% savings time. Now, when they switch over to iMachining 3D, and they made it to 29 minutes instead of 45 minutes, the difference all of a sudden, cutting saves 78%. So on a batch of 140, they saved over $16,000. That is not something to laugh about. That's a lot of money just from one run. Okay. Okay, so now I'd like to go back into the actual presentation itself. And we'll go for a little further into what we're actually be showing over here. Now, what's actually the differences that we've seen in iMachining 2D versus iMachining 3D for prismatic parts? Well, iMachining 2D, as you saw, it required definition of each geometry with its particular chain and its depth. When we did that, this had to be done in several different operations. Whereas iMachining 3D, since it's working on the entire target, it automatically identifies all of the geometries and their depth, and it's able in many cases to perform both the roughing and the rest roughing in one single operation. Now, if you take a look also at a prismatic part, as I mentioned, it did require creating geometries for every single one of the chains, even a part like you see over here. And you can see all of the different operations just to do that. Whereas in iMachining 3D, it's a lot less, a lot easier. You can do, like I said, the roughing and the rest roughing in a single operation. We also have in iMachining 3D, what it uses really is first of all, it uses the proven iMachining 2D algorithm. So the tool paths that we get in 2D are the same tool paths that you'll get in 3D. It's using the exact same type of algorithm. So you'll get those morph spirals, and you'll get those trochoidals where the morph can't get to. And it will actually be doing, what it actually does, it actually it steps all the way down as far as it possibly can with its first steps, takes its deep steps, clearing away the massive amount of material. And then it does what we call an optimized depth of cut, where it starts moving up to different flat areas. Since all that material was cleared away already, now when it moves up, it has a lot less to actually clear away. But not only that, it does what they call an optimal sorting of 2D regions, where it'll work separately on each region before it works in another area. This actually optimizes the positioning between 2D regions. Now, what I'm going to do is actually load another part. So I'll switch over to my other screen. And if I go and open another part, we'll be talking about this part over here. Now, I have the operations done over here already, just like I had before, but there's certain things I want to point out to you as well. As you can see, we have our rough cuts. Our first rough cut, I'm not going to go into the geometry right now. We had our first one that did the outside of the part itself. Then we had another roughing operation for finishing off the floors over here. And then we had another roughing operation for finishing off these floors over here. Now, actually, let me actually stop on this particular operation over here. If I were to open up the operation, you can see that my geometry, since I want to work on these two floors over here, this one and this one, we have one chain around this, and this is an open chain. It's open on all sides. And then we have our second chain is over here, where this side is closed, but the rest of these are open. Okay, we have our tool, no problem with that. But now let's see what happens when we actually run the simulation here. We'll go in and run simulate, and I want to do it actually using Solid Verify. Now, I'm going to actually use Solid Verify, but let me start it from this point, from here to here. First of all, when I do that, you can see the first operations are clearing away all the area, just like I wanted it to, but it's going down to its floor at the very bottom over there, which is fine. It works pretty efficiently this way. Everything's great. Okay? We can see all of this happening exactly the way I wanted to do. You can see that this is the area over here that had the little floor at the bottom, which I'm not machining in this particular operation. Okay? And this was all done. Now, my next operation has to work on these areas over here. Look what happens since I'm doing it in 2D. We have a crash. Why do we have a crash? And that's very simple. It knows these two geometries here. Since this is 2D, it has no idea about the model itself. Now this tool, the way it is, it's a relatively large tool to move this area through this area over here. And it actually crashed into this wall over here, because it does not know anything about this wall. This is not part of its geometry, and this is a 2D operation. So I have to start figuring out, okay, what can I do? Should I use a smaller tool? Should I change some settings inside my operation, not as efficient as they want to? Different things have to be taken into account when I do that. Okay, let me just finish off the simulation that I have over here. You can see it's clearing off these floors exactly where it's supposed to, but it gouged into the part over there. Okay, now let's take a look at how it works using iMachining 3D for Prismatic. Okay, we'll go into the part over here. First of all, note, I have my operation just as before. Okay? You can see I have my target here. My tool, the exact same tool I used in the previous operation, in the previous part, 9.5 millimeters or 3/8 of an inch, sticking out 24 millimeters of cutting. Outside the holder, 35 millimeters. Okay? If I take a look at the simulation this time, you'll see this time, all right, it first does the outside, which is fine, which is what I did also last time. And then it starts working on the inside. Now, since it recognizes the entire target, it knows to avoid that wall where it goes around. In fact, what it will do, it'll actually change its tool path different from what it did before in the 2D so that it can actually mill the entire top of that wall as we wanted it to do in the first place. You can see now it's doing its first step down over here and working on that area over there. Okay? And you can see this time it did not crash into that corner because it knows the target. Something we could not do in 2D. Now, as far as the rest material goes, rest of operation, well, we have this over here. Now, in this particular case, I wanted to prove a little point over here. I am using a cutter, 6 millimeter cutter, fine. On purpose, I'm only outside of the holder 15 millimeters, which I know is short. Now, I have here holder collision actually done. Let me get rid of this for a moment and actually do the calculation of the part. Let's see what happens if I didn't have holder collision. Okay? We'll let the calculation go for a moment. Run our simulation. And as expected, I have a crash. The crash is very simple. The holder itself, as it's going down, hit the part because I did not tell it anything about the holder collision. That's what would happen if I did not have holder collision protection. So if I go back into my operation, I'll just put on holder collision. It makes sure it keeps a specific clearance away from the walls. Let it take its course of calculation. And in this case, it'll do whatever it can, but will not under any circumstances gouge into the part itself. We'll see that in a moment in the simulation. Okay? This time, you'll note it's protecting itself and it's not going all the way down. It's going as far as it can. Now, obviously, with a tool like this, I really can go down, but I just wanted to show you what the effect of holder collision actually is. Now, I'd like to load another part. And this part I'm actually going to start programming together with you. Now, in this particular case, okay, there's a couple of rules that we shouldn't follow, which I'll show you also a little later on, about working on prismatic parts. First of all, with iMachining 3D, you should always define your stock. As you see, I have my stock defined over here. I also have my target defined. All of this should be pre-done. In other words, before you even start your operations, creating that. Also, one other note, if I were to open up the stock, for example, or the target, we have here something called facet tolerance. Keep your facet tolerances tight. Okay? What's recommended is 0.01 millimeters. Okay. Now, my first operation I've already done, and in particular, what I've done is I've actually created a drilling operation down into that area over there. And you'll see why in a moment. I did solid verify. And what we have here is a part with a hole in it, as shown over here. Okay? Note, when we have a hole in it, that means there's no material over here. And iMachining will use this to its advantage. Okay. Now, my next operation, I'm going to start my iMachining 3D. Okay? Note, my target is automatically defined. Now, just to show you, if I go into my working area over here, show 3D, you'll see that this is the stock that it's working on. It already sees that there's no material over there. Okay, so it knows that this is an area where no machining has to be done. Okay. My tool in this particular case, again, I'm going to use, let me see, I'm going to use my 3/8 end mill, similar to the one I had before. And my levels, in this particular case, I don't want to go all the way down to the bottom over there. So what I want to do, really, is I'll just go down to that point over there. I'll keep everything else the same, my technology wizard. Let's go into my technology. In my technology, I have my wall offset. So I'm going to leave my wall offset at 0.3 millimeters. And one other thing we should note. We have here something called rest rough. Now, in my technology wizard, you'll see that we'll be going down in one step. Okay? We will be going down in one step. However, there are steps in between. So what happens in those steps in between, the way it starts stepping up, is controlled by its rest rough. Now, it'll always keep that much material left. That's what we want to have left over for finishing. What we recommend is when doing the rest rough, actually open up your scallop and set this, your scalloping, which is also how much material you're willing to have left over here. So have this set the same as your wall offset at 0.3. Okay? This will ensure that you won't have more material left over than you really need. Let me actually now calculate. And let's see what happens when I actually run the part itself. And while it's running, what you're going to see is that it does what they call the optimal step up. What does that mean? If we take a look at this picture for a moment, you'll see that it'll go down to the very bottom and then start working, stepping up to the first step, to the next step. Let's actually first see this in our simulation itself. Let's simulate. Now, I'm going to start my simulation off slow. You see it's first of all going around the part. I'm actually going to go and do stop on next when it makes a Z change. Okay? So we'll continue the operation. Hold on a second. Did I make a mistake? Yeah. Okay. Let me redo this. Close this up. Stop on next. Z change. And let it run. A little couple of changes over there. Actually, I'll just get rid of this for now. Don't need that. Just go slow. Okay? You see going down. I want to show you what happens when it gets to this area over here. Okay, it's about ready to get to that area. I believe we're about there. Okay. When it gets and finishes its outside area, which it's doing right now, it goes up, and look what happens. The tool is going right over the hole and going right into the hole itself. In other words, since it sees that there's no material left over here, it knows it can plunge in there. It sees what's there. Now let's continue on down, and I'll continue on a little slow over here, because I want to also zoom in to this area itself. And I'll do that by coming in as close as I possibly can over here. And let's see what happens now. Right now, it's actually machining that bottom step over there. And it's doing that in a spiral form. And now it's going up to its next step. This is the optimized step up, as we saw, that I talked about. Okay, if I take a look at this picture again, this is what it's doing now. It did its first step down there. Now it's doing its next steps over here. Step 1, step 2, step 3. And then later on we have 4, 5, 6, and each one of these steps over there. Again, take a look at the simulation. Continue with the simulation. You see now that's actually working in these areas over here. And it's doing what they call the morphed spiral. As it goes up to the next step, you can see the morphed spiral now actually coming into play over here. Now it's doing tricordial to finish off the corners. Now when it finishes off this area over here, which is a deep step over here, it'll go up to this next area over here. And note, the steps over here are not equal steps, but it knows to recognize each individual level. And it knows to machine each individual level as well. Let me go actually on a little further into the part itself. And what do we see? It's finishing off that entire floor, working around whatever there is on that area. Let me slow down now a little. Now look what happens in a moment. It's going to finish off, and look what's happening now. Now it's stepping up to this area over here. Now it has a whole bunch of these steps that it has to do. But note, it's first localized to each area. This is what I call the localization. First localizes and works only in that area, so it minimizes the repositioning of the tool itself, working on each individual step. Now when it finishes this, it just goes up to the top and finishes off the top of this part itself. Okay? This is what we have with the step up, the optimized step up that I was talking about. Now, if I would go back to my other screen for a moment, what you see here is very simple. This is what I talked about, the different regions. Okay? You see it machined each region individually. And this is done with the iMachining 3D performs intelligent sorting. This is what I'm talking about, the sorting into different regions of different 2D toolpath regions. You can see it's actually doing regular 2D toolpaths over here. 3D Z levels, ordering of 2D toolpath regions, as shown. So you have localized machining, which reduces the non-cutting moves. Now, if I were to do this in iMachining 2D, I would have a lot of programming to do. I would have to individually program each one of these steps in order to localize them, like this. Okay? But in iMachining 3D, this is done intelligently. It does it automatically for you, as you can see. Now, some of the rules that I was talking about, let me just mention them again. When you're working on prismatic parts, and just as, by the way, this is true really also with any iMachining 3D, always define your stock and your target models. Okay? And we also recommend that your facet tolerance, as I showed you, should be 0.01 millimeters. Now, we do our roughing and rest roughing, which is what we just did in this operation. We did the roughing, which went all the way down to its very deepest steps, and then the rest roughing actually as it stepped up on the part itself. Okay? And that's the result we get. Now, what about finishing off in the areas where it could not machine? Well, let's go back what we're going to do over there. And we'll be doing what we call is the rest machining with iMachining 3D, with a smaller tool. Okay? Now, with a small, you can do any number of rest machinings. You can go from one size to a smaller size to a smaller size, and it'll always machine only with material, where there is material to be left over. And this is very good for getting into those really tight spots. So let's go back to our part itself again. And What I'm going to do is just do a simple save and copy. Choose a different tool. This time I'm going to choose my 6mm end mill. Okay? And I'm just going to leave it at that. Actually, let me go down to my technology. I have my wall and floor offset set over here. And I'm going to change my rest rough to, again, 0.3 millimeters. Run my calculation. Okay. This will be done in just a moment. And what we're going to see now is how it works exactly on just those individual areas where the previous tool could not finish off the part itself. Right now it's just updating the stock. So this will take just a quick moment. Okay, you can see the part over here. And what you're going to see now is that it's actually machining all of the corners, including those corners over there, which the previous tool could not get into. As shown over here, these corners, even around these areas over here as well. All of them were now machined out exactly the way they were supposed to. And note, the the second tool only worked in those areas where there was material left over. Well, what about finish? On prismatic parts, how are we going to do the finish? Well, what we're going to do is very simple. But before I mention about the finish itself, let me just mention one more thing. As I had told you also before, always make sure your scallop is the same as your wall offset. That's what we call our best practice for this. Now, when we work with the iMachining 2D, if you remember correctly, remember that crash over there? This is what we're showing over there, because the iMachining 2D could gouge the target, as I showed you before. But with the iMachining 3D, since it recognizes these walls over here, it just changes the approach as to how to go in here, therefore avoiding that wall over there. We also showed you exactly the importance of the holder collision. What happens if you don't have holder collision? And what happens when you use your holder collision? Okay? Now, as far as finishing goes, well, we have an entire AFRM package. So let's use pocket recognition. We can do pocket recognition to finish off these pockets. Let's see how this is done. This is done actually very, very simply. You note when we do this, we'll use the option of final cut in our technology and finish on the wall. So what I'm going to do here is just simply go into my part again and continue with recognition, pocket recognition. I'll choose my geometry, which is the entire part. Now note that we have the entire part over here that was chosen. We have our individual faces over here, this one over here, we have this one over here. Note that the top face was also chosen. What if I don't want to do the top face? Well, I can remove it here, just right click or unselect, or let me just accept this. In our modify, we also have an option called exclude top faces. By doing it this way, you don't have to start searching for the proper face to just click on this and it'll automatically take away the top face. As far as my tool, let's use my, I'm going to use this tool over here again, the 6mm end mill. Okay, I have my levels, just my max, note, there's nothing really from here to do. In my technology, I'm just going to click on Final Cuts and Finish on the Wall. If I want, I can even go into my open pockets and say, use a profile strategy, approach from the outside if I have open pockets. Let's see what happens. If we take a look at the toolpaths that we're going to get, now I actually want to see this right now in HostCAD. You'll see that the toolpaths we get is actually inside these areas over here, working exactly on those floors. If I do this with, if I were to go back and get rid of the profile strategy, it'll work this way over here. Okay, so you see it actually finished the wall, worked directly on the floors itself, and then the wall. If I were to do this with Solid Verify, you see it does everything. It does the floor and the wall. Okay. Now, let me go back to my other screen for a moment. Now, the pocket recognition, as you see, provides the most optimal finishing for recognized pocket features. And you saw this was done in one single operation. That's what makes it so easy. Now, let's actually take a look now at programming different parts. Okay? I have a few more parts that I just want to show you. And so I'll go back to my actual working screen itself. And we'll load some other interesting parts. I'm going to close this one. And I'm going to load the part you just saw in the picture a moment ago. Okay? And what I'm going to do is I'm going to use some of the power of AFRM on this part. I'm going to start off with using iMachining 3D. Okay? So we'll go into iMachining 3D. By the way, first of all, you can see I have my stock created over here already and my target. So I'll go into iMachining 3D. Target's in here. I'm just going to choose a tool. In this particular case, I'm going to choose my 12 millimeter end mill. Okay? It's sticking out a total of 45 millimeters from the holder. Okay. Levels, just going to leave that the levels, I'm going to leave it down exactly the way it is. No problem with that. In my technology wizard, you can see exactly what's going on. We have 3 different step downs. And in my technology, I'm going to set this at 0.3 millimeters for my wall and floor offset, as well as change my scallop over here to 0.3. Let's do calculate, and we'll take a look in a moment at the results. Excuse me. Now, when I finish this part, the iMachining, remember I have some other operations. First of all, I have to do the finish, and I also want to take care of these holes over here. So, first let's take a look at our simulation that we have over here. And I'll use Solid Verify. You can see, first of all, that's working in this area over here. And it stays in this area. Note that then it's had this little step up over there. Now it worked in this area. You can see how it's localized. First cleared this area, then this area, now worked over to this. It didn't jump back and forth between the same levels. It first finished individual areas that had to be machined. Okay? Now what I'd like to do is I'd like to work on my finish. No problem. Let's go into recognition, pocket recognition. I'm going to choose my geometry. In this particular case, I don't want to go into these holes as well. I don't want to have those as my geometries as well. So I'll just set my minimum diameter at that and just click on the part itself. Now you can see again, everything is being recognized, the entire part. We have our individual faces, the top face. Now again, I don't want to do the top face. So in this case, I'll just right click over here and unselect. So I can do it actually in both places. instead of going into modify. My tool, I'm going to use, in this particular case, a 10 millimeter end mill to finish off the floor and the walls. I have my levels over there, my technology. I'm going to do final cut, finish on the wall, and in fact, my open pocket contour, I'm going to have it set a use profile strategy and approach from the outside, because I do have those there as well. Let me just run my simulation, and you'll see something very simple. It knows to machine every single floor and every single wall exactly the way it should be. Let's take a look at it for a moment in the host CAD, and you can see the actual toolpath on those floors and the profile operations that we're getting from these open pockets over here. Well, what about the holes? Well, the holes, since in this particular case, these holes were built with the hole wizard of SolidWorks. So I'm going to use that to my advantage, because we have now a machining process specifically for recognizing the SolidWorks hole wizard parameters. And in this particular case, I want to do a work on the countable holes. So I'll click on countable holes and pick. All I have to do now is choose my geometry. So I'll just recognize my geometry. When I recognize my geometry, it recognizes every aspect of it, including the geometries that go around, all of its dimensions. All of this is automatically recognized. You can see all of them that were picked. You can see the entire list over here as well. The only other thing I must do is just choose my upper level. My upper level, I'm going to have that set over here. Insert. And as you can see, all of my operations were created. Okay, run my simulation on that. Let's do solid verify. And you can see I have my drills, my milling operations, and my chamfers as well on the part itself. Even though these holes do not have a chamfer on it, I added a touch of a chamfer on the top over here and as well as the bottom over there. Okay, now what we did over here is basically finish the entire part. I basically did three different things. I did my iMachining 3D, my finish with the recognition, pocket recognition, and I did all of these holes with the machining process, which created automatically 5 different operations. Okay, let me just load another part that I have over here. And this time, I'm going to load this part over here. Now, this particular part, you'll note that it has different Mac positions. One for this side, one for that side, one for over there, and one for that side as well. So if we start with our first Mac position, we have 2 operations that we did in iMachining 3D. We did a regular rough and rest rough and a rest machining. The rough and rest rough, we went with a 8 millimeter end mill. You can see our levels where we want to go down to. I show it over there. I believe it's the bottom of the part itself. You can see the point picked over there. And just going a touch more so we don't leave a burr over there. And in our technology, you can see everything that's set up over here. Okay? If I were to run my simulation on that, you'll see that's actually milling out the outside, everything inside over here as well. All of this is being machined. Now, my next operation, which was the rest machining, is basically the same as my iMachining, my previous operation, just with a smaller end mill. Running the simulation with that tool, what we'll see is very simple. It'll only work in the corners where the previous tool could not work. Now, in my next operation, we worked on the flip side. Now, working on the flip side, it knows that certain areas were machined already. Okay, so if I were to go into the operation, first of all, we'll take a look at the geometry, and then we'll go into working area. Taking a look at the working area show on 3D, you can see that it knows that this was already machined, but this top area was not machined. Okay? I have my end mill that I use over here, my 8mm end mill. Run my simulation using Solid Verify. You'll see that it starts clearing off the corners and then working in around this part over here. And I had to go down a little into that area over there as well. Now my next operation was a rest operation. The rest operation using a smaller tool. If we take a look what this did in the simulation, you'll see that's actually working only in these areas over here, plus in these areas over here, which needed a much smaller end mill. But it knew to only work in those areas. Well, side 3, working on this side over here, let's run our simulation from that operation over there. It sees what was done up until this point over here, but also now finished off this area over here correctly, getting the proper corner that we needed over there. And it knew to machine only that area, as well as this last operation over here, which was the flip side. It has to only work over here. If I were to open up the operation, I'm just going to show you, if I go into my working area, what the 3D material looks like. This is what's left over. So what's left over, basically the machine over here, is just this area over here. So if I run my simulation now, and I'll use the Solid Verify simulation, you'll see that's working only in that area. So what we've basically done here with all these parts is we've showed you how easy it is to work with iMachining 3D on prismatic parts. Now, again, you can do it with iMachining 2D, no problem. It'll work out very well for you. Well, when you have complex parts, when you make complex parts, when you have many different pockets, many different depths, okay, or very deep parts, as I showed you in the very beginning, it pays to use iMachining 3D because that will cut down on your programming time, and in certain cases, like I showed you in the first case, it even cut down your machining time because it was able to go where the previous operation type when iMachining 2D was not able to go, and that was checked automatically. Okay. I see there are no questions here. I'm not sure. Let me make just one more moment. Okay. One thing I should know is that remind everybody, is that this webinar has been recorded, and tomorrow it will be available on our website. So if you did not see the entire webinar, if you came in the middle, do not fear, you'll be able to see it on our site as well. Okay, by the way, also when I do post a webinar on our site, webinars can also be downloaded. If I just go into our site itself, we have our webinars and webinar recordings. You can see, first of all, the last webinars that I've done over here. If I were to click, for example, on this webinar over here, you can see you can actually download the video, not only watch it streaming, and you can also download the parts I used in the webinar. This is true, by the way, for all the webinars I've done. You see I have the latest webinars, different subjects, 2.5D milling, solid probe, turn mill. All of these are previous webinars we've done. and you can check them all out at any time and download them as well. Okay, I'd like to thank everyone for joining the webinar and see you again the next week in our next webinar. Take care and have a great weekend.